Implicit differentiation. Implicit differentiation is where we want to start differentiating functions that look like this. Okay? Everything we've done so far, we've had y by itself. Okay? We've had a function where we had y solved. Now we want to start looking at finding derivatives of functions like this. Okay? And sometimes these might not even be functions, right? Because they might not pass the vertical line test. But we want to start finding derivatives of equations like this. To do that, we're still going to follow all the same rules that we've been looking at. Okay? We're still going to take the derivative of each piece individually. The key, though, okay, the one difference is that we're going to have to use chain rule whenever I'm taking the derivative of y. Okay? Y is a function. Right? So when I take the derivative of y, I have to apply chain rule. Okay, and it's probably just going to make the most sense if we just jump into an example here. And so we're going to follow these steps as we go through an example here. Right? So my goal is to find the derivative of this function, x squared minus y squared equals 16. Right? And then we're going to find the actual slope value at a specific point. To do that, I'm going to take the derivative of each piece. So the derivative of x squared is just 2x. Now, the derivative of y squared, well, that's going to be 2y. But whenever I see a y, whenever I take the derivative of y, I have to apply chain rule. Right here, we did apply chain rule. Right? The derivative of x squared is 2x, then times the derivative of x, which is just 1. Whenever I do that for a y, the derivative of y isn't just 1, it's y prime. Right? Or we're going to use this notation. We're going to use dy dx. So whenever we take the derivative of a y, we have to tack on a dy dx. Right? It's chain rule. 2y, then times the derivative of the inside. So the derivative of y is dy dx. We could write it as y prime or dy dx, but we're going to use dy dx. That'll make our notation easier at a later point. Then what's the derivative of 16? 0. Right? So once I take the derivative of each piece, I want to solve for dy dx. I want this to be the derivative equals something. So I'll just subtract my 2x over. So negative 2y times dy dx equals negative 2x. Divide both sides by negative 2y. And we get dy dx equals, so the negative 2's would cancel out, right? And we just get x over y. Okay, so far? Okay. So we just used all the rules that we've been talking about, right? In this case, we just had to use power rule always. Derivative of x squared is 2x, derivative of y squared is 2y. But whenever we take the derivative of y, we just have to tack on a dy dx. Okay. Then we solve for dy dx. So this is my derivative. Okay, my derivative of x squared minus y squared equals 16 is just x over y. Now, this problem then asks us to find the slope at a specific value. So if I want, and we can write it, we can write it like this. dy over dx of, or at negative 5, 3, we can just throw the point right there. So I'm just plugging negative 5 in for x, 3 in for y. So in this case, that's just negative 5 over 3. we're still using all of our same rules. The only new thing is that whenever I take the derivative of a y, we tack on a dy dx. Okay. So let's take a look at another example here. Okay. A couple more things are going to happen in this example. So I've got x times y plus y equals 8. How do I take the derivative of this first part, the xy? Product. Okay. I'm multiplying two things together. So I have to use product rule when I take the derivative of this. And these are two different things being multiplied together. So how would I do that? How would I use product rule to take the derivative of x times y? Yeah, so the derivative of the first would just be 1 times the second, which is y. Plus x times 1 dy dx. Whenever we take the derivative of a y. So here we did not take the derivative. Over here we are taking the derivative of the y. Right, so this is my f prime, g, f, g prime. Okay. Then we've got another y here. So what's the derivative of this y? dy dx equals 0. So this one, I end up with 2 dy dx's. How am I going to get dy dx by itself now?
Well, subtract y.
So we are going to kind of combine them, but first we're going to have to get this y over here. Right? We want to get rid of the y. So I'll subtract y from both sides. We end up with x dy dx plus dy dx equals negative y. Now what? Any ideas?
Divide by x.
We can't subtract the second word and divide by two. There has to be two words, right?
Yeah.
How about, can we leave the y over on the left and try to get the dy dx?
Well, no, what we've done so far is good. This getting the dy dx's all on one side by themselves is the correct first step. So now, any ideas? Right? I mean, these aren't like terms. I can't just combine them as they are.
Do you multiply an x? You multiply the dy dx on the right and equal to 1.
So we're not going to multiply both sides by dy dx.
No.
Just tell us.
I feel like
Because I feel like we're just grabbing out the same.
So both terms over here now have a dy dx. I can factor the dy dx out of both of these. I can write this left side now as dy dx times x plus 1. Right? I just factor the dy dx out of both of those terms.
And then we get divide by
Right, now I can just divide both sides by x plus 1. So, here, finish that out. So if I divide both sides by x plus 1, I get dy dx equals negative y over x plus 1. So that's this list of steps up here. Okay? Differentiate both sides with respect to x, which is what we did. Then get all the dy dx's on one side of the equation by themselves. Okay, that's what we did by subtracting the y over here. Once I get all the dy dx's on one side by themselves, I can factor out the dy dx, and then, in this case, divide by x plus 1 to get dy dx by itself. Okay?
Could you have done this from the beginning?
Yeah, that. So then, take product rule.
No, I just copied what you did, but I just think you do that
Oh.
from the beginning.
Oh, yeah. Yeah, that would work. Yeah. So, Morgan did it a little bit differently. From the beginning, before taking a derivative, she factored out a y and just made it y times x plus 1 equals 8. Then you could do the product rule with just these two pieces. That would also work. Yeah. You should get the same answer at the end. So now we're not quite done, right? This is our derivative, but we wanted to find the derivative at a specific value. So I'm going to plug 3 in for x and 2 in for y and get out my slope. So negative 2 over 3 plus 1. So we get negative 2 over 4, or negative 1/2 for my slope at that point.
I don't need
Good. Questions so far? Alright, then let's flip over to the back and try a couple more here.
Oh, these aren't on the back this time.
Yeah, it's so
Oh, yeah,
different for us.
They're on the side, just on the next side for you guys. Alright. Do we want to do another one together, or do you guys think you could try number 3 on your own? No, these aren't on the back on your paper. I lied. They're just on the side. What? Do not. I gave everybody this note sheet. Yeah, so we'll have to do product rule for this part. Yeah.
Wait, so that would be multiple.
So yeah, so we can use the 3x as the f. Right? We can say that the 3x is the f, and then y is the g.
So if you do product rule, then that's wait, so for the negative 2y to the second cube.
Is this ish correct-ish?
That would be 4. So here, this is my f prime, my g, and the 3x is my f, and then dy dx is my g prime.
Uh-oh.
That's supposed to be 0. Yeah, because the derivative of 2 is 0, right? Yeah.
So then whenever we take like the 1 and 3y over,
Uh-huh.
what is that? Is that just 3y minus 1?
Negative 3y minus 1, right? We'd have to subtract both of them. So they'd both be negative when I move to the right side.
And then we take the factor out.
Yep. So now we'll factor the dy dx out this side. then we would divide both sides by the 3x minus 4y. Get dy dx equals negative 3y minus 1 over 3x minus 4y.
So we can just leave it like that, right?
Yep, that's our answer. And in this problem, that is the final answer because we just wanted the derivative. Right? It did not ask us for the derivative at a specific value. We're going to skip those for now. We haven't talked about derivatives of exponentials and logs yet. So we're going to skip those ones for now. That's coming in the next section.
That is spooky.
Starting to get the hang of it a little bit. Alright, let's try number 4 here. So on this one, there is not any product rule, right? So that's nice.
Is the key in there? Does it go before the dy dx?
I'm sorry, say that again?
So like the first one, like since like it will become y squared, like 3y squared.
Yeah.
Does it just go after the y, or do we put the derivative? How would I write that?
Oh, yeah. So you would write your 3y squared and then the dy dx like that.
The 5y, is it just 5y?
So even if the y cancels, we still have to put like the derivative.
Yeah. So for this part, the derivative of 5y would be 5 dy dx. Get 2x over 3y squared plus 10y minus 5. Alright. Feeling pretty good with these? Alright, so like I just mentioned, we don't know how to take derivatives of logs or exponentials yet, so we're going to skip 5, 6, and 8. But we can do number 7. This one we're throwing in some trig. We can 5, 6, and 8. Yeah, because those all have either logs or exponentials in them. And number 8 even has inverse trig, which we also have not talked about yet. We will though. Don't worry. Okay, but with what we know so far, we can do number 7. So let's take a look at number 7 here. So I've got the cosine of xy equals x plus 3y. How would I take the derivative of the cosine of xy? So we're going to have to use product rule and chain rule for this part. Right? We've got a couple layers here. So the outermost layer is cosine. So the first step would be taking the derivative of that. So negative sign, and don't change the inside. That one. Times the derivative of the inside. Right, and we'll have the product rule for the inside there. So now we're just taking the derivative of xy. So now that'll just be 1 times y.
X of dy over x.
Plus x times dy dx, right?
The other side.
So now we have to do the other side as well. Now, how do I get my dy dx's on one side and everything else on the other here?
That's a very good question.
But it's vice versa.
So what do we have to do first?
But then that way we get it. Or do we have to exactly you have to simplify it?
I think our first step should be to distribute here, right? So that we have separate terms. So I'm going to distribute this negative sign of xy to both y and x dy dx.
So negative sign of xy times y.
So just be negative sine of y squared.
So the y, we can't combine the y with on the inside. So this y has to stay on the outside.
Where'd you get that outside one?
So I multiply this negative sign of xy times y. And then I'm going to multiply this negative sign of xy times x dy dx as well.
I really don't have nothing.
Alright, so that would be negative x dy dx times sine of xy.
Oh.
One turn to the other side. Add sine of
So now I can add this over to this side, and then I'd have to subtract the 1 over as well to get the dy dx on one side and everything else on the other. So when I do that, so on this side I'll have negative y sine of xy minus 1, and I'm subtracting this one over, and then I'm adding this term to the right side. So equals x dy dx times the sine of xy plus 3 dy dx. So now I can factor a dy dx out over here. Right? So I'll have negative y times the sine of xy minus 1 equals dy dx times x sine of xy plus 3. Right, now we just divide by this thing. And that's just the answer.
I'm hoping.
I think the only thing you can do myself is just like your sine.
Yeah, I mean, it's a lot of algebra too. I mean, so I mean, this is about as complicated as this gets. Right? On this one, once I took the derivative, I had to recognize that I needed to distribute this through in order to get separate terms so that I could isolate my dy dx's on one side. Okay? Are we okay with something like that? I hear one yes and some not so.
I'm okay when we do it together. Yeah, as you can see on Math Excel. Yeah, when I get
Yeah.
one trying to